Okay, so the record is now on. So let's take a look at this. Okay, so from the beginning, again, my apologies for the fact that the drawings is in Thai, but you know, this is from, I don't even know the English name for it. This Sopotho thing, as I said, that this is probably the royal patronage project to provide the school in lieu of the one that was damaged during the earthquake in Chiang Rai a few years back. Okay, I think the drawing itself is not the complete one. So some information is missing and you are therefore required to make some assumptions so that you can design the building. And you know, in real life, sometimes you do have to go ahead and design something, calculate something without the complete information. So you would just, you know, hold your hands up. Why am I doing this? Architects haven't completed the work. Why am I doing this? Well, sometimes you just have to meet the deadline, and yeah, sometimes you just have to do the work that would not be used. It's a pain of the real life, but there's no getting away from it. Okay, and it just means that you have to be quick. You have to be able to say approximate things properly so that your work is simplified, because you know that sometimes even though the first phase of your work will not be used because everything is not completed yet, you should do the work such that if changes are made, it should not really bother you that much in the future. Okay, so here we go. This is the ground floor plan. It's an open space. The important things about looking at the drawings in the first phase, that you must mark where the columns are. Okay, because the most important thing is just column that will send your gravity load down to the foundation, and it is also the part of your frame if you are required to have. So basically, these are the locations of the columns, and you know, I always have fun marking the columns. And back then, when I was your age, there were just, the computers were not really that abundant. So we just print out the drawings like this, and then we try to use the transparent paper and then mark the columns. And now, you know, we have columns here, 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 here. Just mark them like that. That's the ground floor. We probably don't design the ground floor because now when you don't think you know this kind of stuff, it's too much information. Now you are learning. So I'll try to give information to you as much as possible. I hope this will be useful to all of you in the future. Then the ground floor. Generally, we don't use steel for ground floor. You know why? Oh, nobody answers me. It's the because of the exposure, because the ground floor is, of course, you have the soil condition and so and so. So in terms of humidity and, you know, the water content, that it's not friendly for steel. So generally, we don't use a steel for ground floor. We rather use concrete to protect the moisture and those kind of things. Okay. And the second floor here will be your main body of the design. So you better see, you see that? Now you don't have the columns here, you see? This will be just a part of your structure where you need to find a way to support. So when you look at the second floor, here, columns are here, right? Right here, you need to do some extra effort to provide the support for this corridor area. Okay, and you see that when you study the drawings, you look at the span length. For each grid in this distance, it's like 4.5 meters. So that's 4.5 meters. So if you are not going to do anything, this is going to be a one long 18 meters beam. It's not practical to have a beam that is going to be 18 meters long because the depth is going to be large and it will dictate everything. And the architects may not be happy about it also. So you need to find a way to provide the support for this, which we will talk when we are going to design the beam. Okay. So now we go into the roof. That's a very important thing because when you look at the roof, you don't know where your columns are, right? So this is when you need to really mark where the columns are. And you now know it's right here. Yeah. And then you can have columns here at grid line core, right? Like that. And in fact, you can have the columns at some part at grid line core you see? But this is core, right? But you see, the problem is you're not going to have the columns around here. So that means the columns in this grid line core should be the main support for your roof system. Are you with me? Are you with me?
Yes.
Yes.
Yeah, you can see that because you cannot have the columns around here, you see? So that is going to cause some trouble with your truss here because you cannot have columns here. In fact, you may want to negotiate with the architects if it's really necessary to have the columns around here at the corridor. But if you can recall your school, you know, let's say this is what the architects call single corridor. It means that you have a corridor and you have rooms on one side only. If you have room on both sides, it's like apartment maybe, that becomes a double corridor. Now in a single corridor, if your school is a single corridor, nobody wants to have columns around here, you know. This is a corridor, they want clear view. It's going to be quite ugly to have columns around here at the corridor. So chances are you're not going to have the columns around here. So that means the roof system around here from grid number 3 to 7 around here, you need to try to find a way to support the roof system. And since you must find a way to support the roof here with just these columns anyway, that means you can use the same system for the area around here where you can actually have columns coming up from grid right? So in fact, you don't need it. So that means we are going to try to provide the truss system. I should use this one. Your main truss is going to run like this. You know, at every grid line. Are you excited? Huh? Your design project, huh? So your truss is going to be like this. And so on and so forth. And the way we do the truss is you can say it's a main beam, okay? And sometimes for the roof system, we call that rafter. I can write this down as a truss as rafter. So in Thai language, rafter is jantan, okay? And that means this rafter will support, of course, purlins. Purlins will be here. You know, where it's just up to your design, like that. Generally, you should have a purlin to end this as well, okay? So this guy, purlins. And let me write down here. Its spacing is according to roof. Okay, because it depends on what kind of roof you are going to use. And when you know what kind of roof you are going to use, you must provide the spacing of the purlin to support the roof. For example, the good old tiles, I don't know the English word for it, but it's like the tile that is old, so old and hot, that is made of asbestos, and you should not use that anymore. If it's that in Thai language, I call it กระเบื้องลอนคู่ for example. Okay, if you're going to use that, you need to know how you have to place your purlin so that they can install that kind of tile. Are you with me? When you know the roof, okay, you will know the requirement for the purlin. This is somewhat automatic because good engineers will know right away when they see the type of the roof. It's right here. See, lonคู่ here. And as I say, they say it here that this is lonคู่ ไม่ผสมใยหิน with no asbestos, which is, it should be illegal throughout the world because asbestos is materials that can cause cancer. So anyway, I think you can change the type of the roof. I would not say that you have to use this one. I myself don't like this kind of roof at all. I think it looks ugly, and without, say, the insulation, your room is going to be extremely hot. So I'd say right here, choose your own materials. Okay, so that means you guys don't have to have the same kind of materials for your roof. Okay, this is part of your project. Do it with yourself, do it with pride, and this is the real thing. If you can do this by yourself from the beginning, you should be able to do real work. Okay, in the real world, in this part, if you don't choose it, architects will choose it for you. It's your job to know the material, and when you know the material, like the one very popular right now, like the news tile, they call it. It's news tile. I don't know how it is the spell. Maybe it's something like that. It's not news, like you're watching the news. Not the same. You would know. Okay, the requirement would be your purlin must be spaced at every 1 meter, but maybe 1 to 1.2 meters, but no more than that. If you really cannot find the information, you can ask architects. Okay, it doesn't hurt to ask them, but the more you do it, this becomes in your system. So when you see the type of roof, pop, you just know right away. Okay, and for example, if you choose this, okay, I need the purlin at every 1.2 meters, but you cannot have spacing larger than the requirement, but you can have it smaller so that you can space them nicely in your roof plan. Okay, so you choose your own materials, then you will know what kind of spacing you need for your truss. Okay, but remember, this will give you not only the spacing that you should base your truss configuration on, it will also give you the weight of the roof. This guy, lonคู่thing, is pretty light, very, very light. So it's kind of, okay, friendly. I think it's only 7 kilograms per square meter. 7 per square meter. It's very, very light. But don't forget that no matter what you choose for this, it gives you the information about the date load. You must also study the law and apply the live load on the roof as well. Okay, so this, choose your own, so you know the spacing and you will also know the date load. Okay, and you must also add the live load. So don't forget live load. Okay, so you must check the law. So basically that is pretty much the roof for now. So do you have any question about this before I go further? I'm not asking you to design just yet. I'm asking you now to try to clarify every design criteria you are going to use. Okay, so you can look at this document which I just posted. See, study the building code to find the load, and then this is number 2. You are going to, choose the type of the roof that you are going to use, and that will tell you what kind of truss configuration you should use, and so on and so forth. Okay, that's for the roof. So any question? No question? All right. So let's when you see this drawing, you see this symbol, right? There's a section core and section core. So but the 2 sections are cut and then they look this way and then that way. So the drawing on the section do not really show the fact that you don't have columns here. So when you come see these drawings here, see, it shows the columns, but because the direction of this section doesn't reveal the corridor, you see. So you don't really see the fact that you don't have columns at the corridor area. Are you with me? Hello?
Yeah.
Yes. So when are you going to propose a toast? Okay, anyway, this means that when you face a problem like this, you don't hide by saying, hey, architects, don't show me this. The 2 cross sections, they look this way, so you see this instead, and then this one looks this way, so you see this part instead. It doesn't show the most important information that you need. That is, at the corridor you don't have columns. When you face a problem like this, you must try to, verify this from the beginning with architects. You don't, because we work together, we share the ultimate goal that we want to build buildings for people. So when information is not present, when it's not complete, you better talk to them so that you draw, you will design the proper structure. We're not on war with them. Okay, we do not do work to try to find who's right or who's wrong. When the information is not there and you know it, you better ask them what's going to be around here. Okay, we're not playing games. We do structures for people. It's our pride and joy. So once we know this, you can come and take a look at this cross section, knowing that in fact you will have the columns at here instead, and here. Okay, so your truss will be something like, with a cantilever portion. So it's going to be like this. to your truss. Okay. There is this part that is not clear and I don't like, because if you extend out this portion out of the truss, it will your top chord member will no longer act like a top chord member because it's going to have bending moment. So let me clear the overhanging portion with the Suchat, how he wants you guys to do it. Okay. So there we go. Your first headache. You're going to have a truss that is not really symmetric. Okay. It looks like that. Now, the second thing that you need to know is that when you look at this truss, it's your job to design the truss. This drawing is done by architects or the drafts people. So they don't really know what the truss is going to be. They just put some picture there. So you as engineers, it's okay. Oh, I have to do the truss like this. No, you don't have to. Okay. It's your job to come up with the proper truss configuration. Okay. It's not even a proper excuse to say that, hey, the drawing is like that, so I'm designing my truss like that. No, it is your job. You are an engineer. So you must pick your proper truss configuration. This is not the most proper one, okay? And let's say no one will see it, because chances are they're gonna put some ceiling underneath it. So that means when you study the configuration, you go back here and you know that not only that your truss will have to support the live load of the roof and the dead load of the tiles, the roof type that you use, you probably have to consider the ceiling as well. What kind of ceiling you want to use, and do you want to have insulation maybe? Something like that. Okay, they're not that heavy, but it would be nice if it has been included in your consideration, because let's say in the future the architects may come, hey, is it okay if we add ceiling? Because nobody wants to see the truss in the room. Let's say even if this is not a school, maybe it's an apartment or something, or you know, say in the end that is, you know, out of politeness, because generally if they ask you like that, it means they want to add it. Okay, so you better be prepared for this and then add some more load in here. And now I think I have the two drawings in this. One more thing, and the fact that I say, you know, they just put the drawings there because they know it has to be the truss. How it is going to look like, it's completely up to you. So please notice that you see the purlins, they're not on the joint, right? It's just a drawing that doesn't mean anything, because this is not structural drawings. So people are not going to build a truss based on this picture. It is your job, you know, to set up the purlins on the joint. And now you know that the spacing, it's going to be true here, because you cannot have one because of the slope. Okay. And you would know spacing from the type of the roof that you choose, and therefore it's your job to provide the truss configuration so that the joint is there underneath your purlin. Okay, is there any question? So that is a truss for you. Your first phase is just to make sure about the loading conditions and so and so. That's the first thing. Please don't hesitate if you have questions, okay? Now, generally, when you build something, you build from the bottom, right? But when you design something, you design from the top, because you need to keep finding the support for your structure. Now, it's a second floor now. Let's say I say you can change the type of the building. It doesn't have to be school. It's okay. But if you change it, even if you don't change it, you need to find the live load, which depends on the occupancy. And you have to look up the load. Okay, this is part of your design process. The criteria must be done by you. All right. And the date load, of course, choose the floor type. I mean finishing. Okay. Now, one thing that you probably don't know how to do it just yet is because if you are going to calculate the date load of the floor, you need to select the floor. Okay, and say this is 4.5 meters long, so you can actually select the floor that has the 4.5 meters length. We are going to select the choose finishing. The finishing is not the floor. Okay, you are going to have to. I'm trying to write a note so that you don't have to memorize all things. Select floor type. And we are going to use the, let's say, hollow core concrete, okay? So this 4.5 meters, in fact, they are fine. So you may only need to have beam here, and then you can put the hollow core in that, that direction. Oh boy. 4.5 meters is pretty doable. Okay, so for those of you who want to go ahead and try to study how you can select the hollow core, you can do so. I can provide the tables for the hollow core that you can pick from. And the thing is this, now you know when you select the hollow core from the catalog, you know the span length now, right? It's going to be 4.5 meters. So you go to that span length and you will know the load from the live load of the building based on your occupancy and from the finishing. And from then on, this will become something that we can call super imposed load. Are you still with me?
Yeah.
Any load
Yes,
that okay, good. Okay. Any load that your hollow core will have to carry is called the superimposed load. So we are talking about every load thrown on the hollow core except its own weight. Hollow core self weight not included. Okay. If you can, I will try to post the information about the hollow core in here, and you can use that to select the hollow core. And once you know the hollow core, you will know how much your floor weighs. Okay. and that you can go ahead and try to approximate the load that your columns have to carry. Okay, I was going to say something. You may not need hollow core because 4.5 meters is not long. You may use the another floor, which is lighter. It's called precast concrete slab, or sometimes it is called plank. If you want to use this, the plank is only 10 centimeters thick, so it's pretty small. But if you choose the live load that is large, because the plank is small, so if you use 4.5 meters for your span for the floor, that plank may not be enough. So you end up having to use the hollow core, which is thicker and stronger and more expensive. Another way that you can do, it's entirely up to you, is that you may, because if you succeed in reducing the floor, your system is going to be quite, economical. Another way that you can do is that you add more beam here. Okay, so you have the main beam like this, and you add another beam. So now that means, alternatively, add more beams. When you add more beams, that means the span of your floor will now reduce in half from 4.5 to 2.25. If you have a heavy load, this is the way to do it. Add more beams so your floor becomes smaller, and that means the overall weight of the structure is also reduced. Okay, so this is up to you if you want to challenge yourself, because this is your playground now. You can do anything, you can try to explore anything you want without feeling the pressure of, will this building stand? Is it going to be okay? Is it going to collapse? Something like that. So it would be a nice idea if you could add this. Okay. And of course, incidentally, the size of the beams will be smaller too, because now you carry the weight like twice less. Not twice, it's a bad way to say it. 2 times less. Okay, that's better. All right. And then in the end, I would suggest that you need to have the cantilever portion out like this to support this out from the main beam, but we can talk about this when we design the beam. Okay, that and that. All right, so I think that pretty much covers everything I want. If you can select the floor, because I don't know why last year it was so confusing the way they try to choose the hollow core because of this. When you look at the hollow core table, it shows the superimposed load, which means that if you know the load of the finishing, if you know the live load, you add them up, you have the superimposed load, you can just select the hollow core right away. But when you want to try to sum the load that your columns have to carry, you have to add the weight of the hollow core itself. So they got so confused. What's the load? Do we have to add it here, then? I was, wow. Is it? So if you could choose the floor, That means you now can use the tributary area to calculate the load that your column has to carry. For this column, it's going to be that one, right? For this one, because it's a cantilever, so it's going to be this much. Okay. I'm not sure if Ajahn Sutat wants you to design this as a column in the frame. I'll talk to him, but you should try to, take care of the criteria of the load and try to calculate the tributary area and the load that each column has to carry, because in the end you have to use it anyway. Okay. So any question?
Could you explain a little bit when we add the beam in the between the column will reduce the weight, since it can have the floor that plays all the entire space?
You mean this one maybe?
This one that you draw. Yes. Why you mentioned that it reduce the weight?
Okay, let me explain about that again. The thing is this: when you add the additional beam, what will change is the span length of the floor, right? Remember that in steel construction, we generally use either metal deck or hollow core or the plank. So it's a small beam placing like this. Okay, so that's a piece of hollow core. When you select the hollow core or the plank, this becomes the, I shouldn't draw that. This becomes the span length of the hollow core as a simple beam. The hollow core is also a simple beam put on the steel beam, which is a simple beam as well. So when this span length of the hollow core is long like this, 4.5 meters, the bending moment acting on the hollow core is WL squared over 8. Am I correct?
Yes.
Now your L is 4.5. So when you reduce the length of your hollow core by half, it means you reduce the bending moment 4 times, because it's WL squared over 8. So when length is 2 times longer, bending moment is 4 times greater. So chances are, when you're dealing with a heavy structure, you reduce the span length of your floor, the size of the floor will be significantly smaller than the size of the floor with the longer length, correct?
Yes.
So the size of the floor here with this 2.25 meters span length should be significantly less than this. And when the floor is less, that means the weight of the floor, of the entire floor, of this entire system becomes less. So the weight that the column has to carry also become less. And it goes into the foundation, that your foundation will probably carry less. So you require, smaller number of piles, for example. That clear?
Yes.
Okay, good. So let's summarize your first job, design phase 1. I am not saying, okay, Napat, go ahead.
How about the composite construction that you mentioned in the first lecture? Is that another choice for flooring?
Yes, it is. But if we, let's say, because we don't have time to talk about composite will help reduce the size of the beam, because you now use this floor as part of the beam. So the beam will become stronger, That means the result should be that your beams will become smaller, but the floor will remain the same. Because there's nothing you can do but the floor, the requirements is there. You need to select the floor type so that it can hold the load. But if you choose to use the floor as part of the composite structure, the size of the beam can be further reduced, and may I add significantly as well. But if you choose to have the composite structure, what you must make sure that you have is the composite action between the concrete floor and the steel beam. And by that, we will add the shear connector. Okay, it doesn't affect what we are doing at this stage yet, because you can just select the floor, you can select the load, and this one will remain the same. But let's say in the future, if you are equipped with the proper ability to handle the composite, you may say, I want the composite action, and therefore you can save the expense on the structure even further. But yeah, there's a pros and cons, because you have to pay for the shear connector as well, right? And this is your first adventure into, you know, the true engineering work. So I really don't mind if you have a lot of questions, if you want to discuss about this, but I say you better try to do as much as you can, because the questions will come when you do the work. If you don't do anything, you don't know what you don't know. Mark my words, you don't know what you don't know. So you have to do something. You will encounter a lot of questions. Nobody to turn to. You can, you know, try to collect those questions and ask me in the next design lab next Tuesday, because the purpose of the design lab is so that we can spend time discussing how you're going to handle a problem like this. And the experience you have from here will be the experience that you can use in your real work in the future. Okay, Napat, is that okay?
Okay, I just wonder why you mentioned just HC and precast lab only.
Or you mean metal deck?
Yes.
Yeah, you can create the composite system out of hollow core and precast. You can use the metal deck as well, but the reason that I didn't mention the metal deck here is because the span is pretty small, and in this country, a hollow core and plank are cheap and very easy to find in the market, and so we can easily use this. And in the real world, you are likely to use this more than metal deck, but that doesn't mean that people don't use it. Okay. But metal deck, the way that it has to be installed into the system requires the shear connector anyway. So in metal deck, if you use it, it becomes a kind of automatic that you're going to have the composite structure. But here, hollow core and plank, you can use it with the steel structure. You may or may not choose to have the composite action. But in fact, you know, if we talk about choosing something, even if you use metal deck, you may choose not to have the composite action as well, because, you know, some engineers do that. Why? Because they're not really sure about the shear connectors, maybe, or they don't know how to handle the problem. So, which is kind of sad, right? You're right, the capacity is there, and if you truly use this, see how much money we can save. But you know, I have some experiences that I can share with you, how, you know, I encountered the work that people have done in the past, and then I don't agree, I change the details, and then the fabricators just got, wow, you sure you want to do that? I said, absolutely. I said, wow, great. Because, you know, people keep adding things on the steel structure because they don't know. When they don't know anything, they don't feel safe, they keep adding things. I say, I don't need that. I don't want that on my structure. The fabricators never seen anything like that before. And it just, are you sure? You don't want that? I say, I'm sure. And that is probably, I remember, it's probably the last structure that I was involved in the design. Because afterward, it just, the work is hard to come by, but that's another problem. Okay, so is there any more question regarding this? To sum it up, you need to verify your criteria for the roof load, and for the load on the floor, figure it out and try to select the truss. Again, this work is not due. It's not enforced yet. The first work that you are going to submit is the design of the truss right away. So that means if you want to be sure, if you get the load correct and so on, so you can submit your work for, say, the rough check. We can just roughly look at your work and see, yeah, you got the load okay, and so on and so. Because when I ask you to submit the truss design and you mess up the load, everything is garbage right away. You understand that, right? You are going to design the truss in the real world and then you mess up the load. How can that be considered structure, right? The load must be real, must be correct. And therefore the structure that you design to support it is, legit. Okay, that's first hour. So let us have a break here for 10 minutes, and we're gonna come back in the second hour and say if you have any questions about this, and then if yes, we continue to talk about it. If not, may I ask you to just go ahead with the design examples of the compression member. Okay.